Hello everyone, welcome to my YouTube channel. I hope you all are doing good. So without wasting much time, let's start the video. Today's video is about non-primitive data structures, and I have already explained about primitive data structures in the previous video, and the link is given in the description box below. So without wasting much time, let's start the video. So non-primitive data structures. What are non-primitive data structures? Non-primitive data structures are more complex data structures, and these are derived from the primitive data structures. As we have classification in the primitive data structures such as integers, float, characters and pointers, we have the classification in non-primitive data structures. Also, those are arrays, linked lists and stacks. Let's check out one by one. What is an array? An array is a collection of homogeneous elements with unique name, and the elements are arranged one after another in adjacent memory locations. Here we have an array of size 5. That is nothing but the size of this array is 5, and it can store maximum of 5 elements in it. And those elements are represented by subscripts or indices. For example, if I wanted to know the location of the element number 4, then the subscript or indice is a 3, and the elements stored inside the array are called as elements. I will make a separate video on arrays. For time being, just know only this much. And in that video, I will explain everything in detail about arrays. That how to add an element or how to delete an element from the array, and also I will show you practical by writing a program. And also please note that if the array is full, then we state that it is overflow, and if the array is empty, then it is called as underflow. And this is just an example I have said you. There are even more types in the arrays, and those are one-dimensional array, two-dimensional array and multi-dimensional array. For your convenience, as this video will be longer, I will make a separate video on arrays. Now just keep in mind that in arrays, we have to pre-decide the size, and the pointer called as top is placed at the end of an element, which locates the elements are called as subscripts or indices, and the elements inside there are called as elements. I hope it is clear. Our next topic is stacks. What is a stack? A stack is an ordered collection of items where the addition of new items and removal of existing items always takes place at the same end. Assume you start out with a clean desktop. Now you place books one at a time on top of each other. You are constructing a stack. Consider what happens when you begin removing books. The order that they are removed is exactly the reverse of the order that they were placed. Stacks are fundamentally important as they can be used to reverse the order of items. The process of adding the items or books is called as push, while the process of removing is called as pop. And the order of insertion is the reverse of the order of removal. This principle is called as LIFO, last in first out. One of the examples is that every web browser has a back button, right? As you navigate from web page to web page, those pages are placed on a stack. Actually, it is the URLs that are going on the stack. The current page that you are viewing now is on the top, and the first page you looked at is at the base. If I click on the back button, you begin to move in reverse order through the pages, and this is where exactly the stacks are used. I have just given an example of web browser for your better understanding. And the last one is linked lists. The size of the array needs to be fixed to store the items into the stack, as I have said right while explaining about arrays. And if the stack is full, we cannot insert an additional item into the array. It gives an overflow exception. But in linked lists, we can increase the size at a runtime by creating a new node. So it is better to implement stack data structure using linked list data structure. And this is how the linked list actually looks like. These are called as nodes, while the numbers in the nodes are called as elements. And always remember that the top is always placed in the first node. But in case of arrays, it, we can increment or decrement the pointer top, but we couldn't add more elements. If the stack is full in an array but in linked list, we can go on adding as many as elements we require. Let's check out by adding some elements in the linked list. Suppose I wanted to add number 10, so I call the operation push 10. As the pointer top is locating at the first node, after adding the element, this is how the linked list looks like. And again, if I want to delete or remove an element, I call the operation called pop. Always remember that deleting of an element always takes place in the first node in linked list. After the pop operation, my linked list would look like this. I hope you understood what is an array, what is a stack, and what are linked lists. And don't forget to check out the full video about arrays. If you have liked my way of teaching, then please subscribe to my channel for more videos. And don't forget to hit the bell button to receive instant notification as soon as I post more videos, and share it to your friends. Thank you.